Stability is about being in a fixed position where movement is less likely due to the stability of a person or object. Stability increases in a supporting situation when a person bends their knees, takes on a wider stance, lowers their centre of mass or centre of gravity, and engages their core strength. To increase a person's stability, a greater base of support is also required. A greater base of support is gained by increasing the width of the legs. This also means that they are holding a stronger position, meaning they're less likely to topple and lose their balance. For example, in a box out and rebounds, when a person blocking the opponent from getting towards the basket to get the ball, the player has to be stable so that they can't be pushed out of the way. In order for them to be stable, they must have a wide base of support, legs bent so they're closer to the ground. This means that the player will be more balanced and less likely to be pushed over. They're acting as a physical barrier using their core muscles and strength. Stability is reduced when a person is unbalanced as they are unstable. Instability is when someone has a lack of stability or balance, meaning that movement is likely of a person or object. To decrease stability, a small base of support will be made, making a person unbalanced. Taking a narrow stance, standing upright with no knees bent, and not engaging core muscles or any muscles, so that they are weak and not strong. Having high centre of gravity as well. All of these factors work together to make someone more unbalanced. If someone is more unbalanced, they are easier to push over or fall over. In a game of basketball, a person may become unstable if they have taken a wrong stance. Like I've just described, if someone was running, for example, they are likely to become unstable and fall over if in a basketball box out and rebound they take on a very weak stance. The opposition is likely to come and lean on them and push on them, and if they are very unstable, then they're likely to fall over or fall forward. Centre of mass is an imaginary point where all forces are balanced. It's essentially the rough average position of all the parts making up a system. For example, in basketball, the centre of mass would be located directly in the centre of the ball. When standing in the anatomical position, the centre of mass would be exactly at the belly button. The centre of mass can be located outside the body also, but it's not a fixed point, and so there is change. The centre of mass will move according to how the mass is distributed. Mass is how much material of an object or structure of an object. When a player in basketball reaches up high to retrieve the ball from the air in a box out and rebound, their limbs are moving up due to their arms being in the air. This therefore results in a higher centre of mass than before when they had their arms beside them. Base of support is the area beneath an object or person, including every point of contact with the object or person on the surface. It can be between 2 points of contact. If a person is standing upright, their base of support would be between their 2 feet. If a person was then holding a walking stick, which was also touching the ground, then the person's base of support would be 3 points of contact. Base of support ties in with a person's balance and therefore their stability. The larger the base of support, so a greater width, the more stable a person will be. Staggering feet front and back like this is one way to increase an individual's stability. For example, a basketball player may widen their base of support if they are on the defense and expect an opponent to make contact with them. By widening their base of support, a person will be more balanced and so more able to take the impact of the opponent bashing into them. This stops them from becoming unbalanced and potentially falling over. So there is a relationship between base of support and stability. Next, line of gravity is an imaginary line that runs down from a person's centre of gravity to the ground surface. The line runs vertically down to the surface that the person or object is on. The closer the line of gravity is to the centre of the base of support, the more stable a person is, due to the fact they'll be more balanced. When the line of gravity falls from outside the base of support, if the line of gravity falls outside the base of support, then a person will become unbalanced and will need to regain stability, otherwise they will fall. A lower centre of gravity means better balance and stability, and a shorter line of gravity between the centre line of gravity and the ground also means better balance and stability. Method of collection. So the method involves many different aspects. The first part of the method involves participant preparation. The preparation involves a PAR-Q completion. This is a physical readiness questionnaire that asks a participant about their medical history and physical history to make sure that they are safe to take part. The participant will then be required to fill in an informed consent letter. This informed consent will essentially tell the participant what they're about to take part in and the risks involved. The participant is required to sign it to give their permission and understand what is required of them. The next part of participant preparation involves telling the participants the detailed protocols of what they will do, how they will do it, and making sure to keep the explanation of the method as standardized as possible, so that each participant has the same understanding of what they're going to do. The techniques need to be understood by each individual and carried out the same way by each person. This is because differences in technique can affect the results. Someone who uses their arm will generate more power and therefore will be able to jump higher than if someone doesn't use their arms. In a box out and rebound, a person would use their arms to generate power and so they can retrieve the ball from the air. They may then do a warm-up, which will be again standardized. The warm-up needs to be exactly the same for each participant, as a warm-up will affect the ability a person has to jump and therefore their results. A participant who warms up a greater deal will have warmer muscles, increased flexibility. If they have increased flexibility, this could mean that they have a greater advantage of jumping higher compared to someone who hasn't warmed up properly. The next part of the method involves calibration of force plates. This is when the force plates are reset to 0. At the beginning and after each person has done a jump, the force plates need to be calibrated, and also whilst the person is standing on the plates. This is to make sure that the plates are accurately measuring each person so the results are trustworthy and reliable from each person, one person to the next. The force plates should be 0 with the person stood on them. So the force plates are first zeroed. The two plates also need to be synchronized so that they're measuring the jump equally and the same. The method of the experiment we did involved, so first of all we used a gynecometer to measure the angle, so the bend in the knee, and the two angles we used were 90 degrees and 135 degrees. The first jump that we did was the 90-degree angle. The individual would first familiarise themselves with the feeling of the angle or the bend, then they were allowed to do the jump. So they would step onto the plates when asked, take a wide stance as so to represent a jump in basketball box out and rebound. The instructor would then count the person down and they would jump, landing back on the force plates. They would then come off the force plates while the results were being generated and passed to the computer. Each person did 3 jumps for each angle, and after each jump the force plates were calibrated. So involved bend in the knee, jump, land on the plates, step off. We did 3 jumps so that an average can be taken as well. So if the individual did maybe a bad first jump, then they'll be able to get more used to it in the second and third one. So by doing 3, it's more representative. So the next thing to think about is when recording the jump, thinking about the cameras. So the cameras being used to record the jump need to be adjusted, taking into account many different factors. The setup of the camera is crucial to capturing all of the jump, including the height, making sure it's within the frame. The quality of the camera, the positioning, the setting, capturing the detail, etc. The camera preparation involves looking at the tilt, roll and pan of the camera. Roll is to do with, is making sure that the level is flat and isn't rolling. The camera should be perfectly level and not slightly tilted to either the left or the right. The tilt of the camera is also the level of the camera. The vertical tilt of a camera setup. This is whether the camera is pointing upwards or downwards. If the tilt of the camera isn't level, then it will essentially change the perspective of the video. And then pan is to do with panning a shot, essentially meaning following the movement. So in a box out and rebound or a jump, the camera would be moved or panned so that the whole action can be captured, as when jumping in the air, sometimes if the camera was kept still, the person may jump out of shot, meaning the whole action isn't captured. So the camera needs to be panned as the person may jump up and the whole movement needs to be captured basically. Next, a person needs to have a reference of the distance the person with the camera is from the movement taking place that is being captured. This should be both horizontally and vertically. Horizontal scaling means that the scale needs to be given, which informs how large the distance is from the movement to the camera. This can involve measuring the distance via a meter stick or something like that from the camera to the action. Vertical reference also needs to be noted so that the camera can be set up in exactly the same way and exactly the same positioning if someone else was to repeat it. Having the camera at different angles can skew the perspective. This is known as perspective error, which can lead to false conclusions being drawn. It is when a person or object appears to be changing in length when it moves out of the calibrated plane. Taking shots from different angles is best so that the motion can be seen from a range of perspectives, meaning greater detail can be observed, whilst only having one perspective can mean that important aspects of a motion are missed or misinterpreted due to not being able to see the whole person properly. The planes of motion and axes that are involved also need to be considered. For example, in a box out and rebound, they would all be in the same plane, known as sagittal. It's important that the setup of the camera is in the correct place and that the planes of motion and axes for the movement are known in advance, which will decide where the correct or best camera positioning would be. Triangulation is when a person is placed in the middle of the frame. Cameras are set up in a triangle around the person completing the movement so that images can be captured from different angles and perspectives. The setup forms a triangle with the person at the heart of the centre. Shutter speed of the camera also needs to be considered. This is the frame rate. It's the number of frames that occur of the video per second. To capture the detail, a high frame rate is needed, which means a high sampling frequency. To capture the motion, a high-speed camera would be needed, and a super slow-mo one that takes 1,000 frames per second. If it's really slow, then footage will be blurred and bad quality, so a high-speed shutter rate will improve the quality of the images. A high frame rate provides greater quality and detail as there's a greater sampling frequency. It's measured in frames per second in hertz. So next is the focus of the camera. Depending on what is being recorded, the focus will be adjusted. The focus of the camera can either be automatic or manual. Manual is when the setting on the camera means that someone can by hand manually control the focus, allowing a person to adjust it during the video, whilst automatic is when by itself the camera changes its focus based on the movement that's in front of it. It's much more risky to do automatic as manual, as sometimes automatic can lead to it being out of focus or something, so manual is considered better as it means that you can straight away see if it's in focus or not. 3D and 2D imaging can also be used. For 3D imaging, Vicon cameras can be used. They provide a 3D perspective which allows for the motion to be captured from all the active cameras. These are very high-tech cameras which can be very expensive, but they do enable a 3D image with length, width and depth to be gained, whereas 2D imaging, a normal camera can be used, such as an iPhone or something like that, which is much cheaper, however doesn't grasp the whole action in many different planes and axes, and from a 3D point of view. Digital images are made up of tiny pixels. Zooming into an image can make the image quality quite fuzzy, grainy and blurry, but by using a good high-tech camera can mean that when a camera is zoomed in, each pixel is very clear and they continue to stay at a high quality. The more advanced cameras have a greater quality and the digital images come out much better.